An AI that can read your x-ray and spot a disease, that isn't science fiction anymore, it's really happening. So the real question isn't if an AI can do it, it's how well can it do it? How do we grade it? And maybe most importantly, how can we be sure we can actually trust it with our health? Let's dive in.
Because at the end of the day, it really all comes down to trust, right? I mean, before we let an AI even get close to acting like a doctor, we need a super reliable way to measure its performance to make sure it's making the right call. So how in the world do we do that? Well, probably the easiest way to think about all this is like a report card. We need a clear, standard way to score how well an AI does its job. And believe me, in the world of medical AI, there are some very specific grades that really, really matter. Okay, so the key metric we're going to be looking at is called the AUC score. Honestly, just think of it as a letter grade. A perfect 1.0 is an A+. A point 0.5, that's an F. It's no better than just flipping a coin. So what this score really tells us is how good the AI is at telling the difference between someone who has a condition and someone who doesn't. So let's take a look at the report card for an AI that's been designed specifically to read chest x-rays. This is our baseline, our starting point. How does it do right out of the gate? And the initial results are they're really impressive. For most of the conditions it's searching for, it's scoring between 0.85 and 0.99. In school terms, that's like getting solid B pluses and A pluses across the board. This AI is already a pretty strong performer. Let's get specific. For finding a condition called effusion, which is basically just fluid around the lungs, it scores a mind-blowing 0.991. I mean, that is incredibly close to a perfect score. It's almost flawless at spotting that one particular issue.
And it's not just a one-trick pony. For detecting an enlarged heart, what they call cardiomegaly, it scores a 0.933. Spotting a mass, it's up there in the 0.95 range. So clearly this is a very capable AI. But, and there's always a but, isn't there? It's not perfect. And here's the catch. When it comes to finding emphysema, the grade just plummets to a 0.644. Now that's still better than a random guess, but it's like a D-, It's a major weak spot, and it shines a big bright light on where this thing needs to get better.
So the verdict is in. We've got a really strong AI student here that aces most of its tests, but it's really struggling with one important subject. The big question is, can we help it study smarter? Can we actually make it better? And this is where a much smarter approach comes into play. See, the problem might be that the AI is only using one of its senses. So what if we could give it another one? The original AI is what's called unimodal, which just means it only looks at one kind of data, the X-ray image itself. Think of it like a doctor who only ever looks at the picture, but never bothers to read the patient's chart. A multimodal AI, on the other hand, does both. It looks at the image and it reads the radiologist's written report. It gets the whole story. So the hypothesis here is actually pretty simple, but it's also incredibly powerful. If we combine the AI's sight, its ability to see the image, with its ability to read, to understand the text notes, we should get a much more accurate and much more reliable AI.
So, did it work? Was giving the AI a second sense the big upgrade it needed? Well, you know what they say, the proof is in the numbers. So let's go check out the new report card.
All right, here are the results. On the left side, that's the performance of the original AI that only looked at images. On the right, that's our new multimodal framework, the one that reads both the image and the text. And that final column shows the percentage improvement. We're going to break these down, but even just at a glance, the story is pretty darn clear. Let's just focus on one key metric for a second: average precision. This basically tells us how good the AI is at making the right diagnosis without raising a bunch of false alarms. The original model scored a 0.78. The new, smarter model, it jumped all the way to 0.87. That is a massive leap in performance. Okay, next up, the F1 score. Now this is a really important grade because it measures the balance between being accurate and, not missing stuff. And here we're seeing almost a 12% improvement. That means the new AI isn't just more accurate overall, it's also way more reliable at catching what really matters. And just to hammer the point home, if we look at that average precision score again, this time just as a percentage bump, it's up by 11.5%. This just confirms it. The AI got so much better at making correct positive diagnoses. It became more confident and more correct at the same time. Look, the result is just undeniable. By teaching the AI to not just see the picture, but to also read the notes that go with it, it became smarter, more accurate, and just fundamentally more trustworthy.
So why does this one experiment matter so much? What's the bigger picture here, beyond just this one AI model? It matters because this gives us a blueprint. It's a simple 3-step recipe for building better AI. You start with a model that's a specialist at just one thing. Then you give it a new sense by adding another related type of data. And the result? You get a much, much better, more holistic intelligence. And this idea goes way beyond medicine. I mean, just imagine it. Apply this to financial analysis, or legal documents, or even engineering safety checks. Any complex job where context is absolutely everything could benefit from this kind of multimodal approach. This is how you build smarter, more reliable AI. Which leaves us with one final thought to chew on. We just saw how teaching an AI to see the full context made it a way better doctor. So what other huge, complex problems are just sitting out there, waiting for an AI that's finally been taught to see the whole picture?